begin. So first up, good morning, good afternoon and good evening to everyone, and welcome to our first digital press conference. My name is Georgia Azar, and together with my colleagues, I run the International Passivhaus Association, which is a global network of Passivhaus stakeholders, which includes architects, tradespeople, scientists, property developers and owners, manufacturers and policymakers. So a very varied network. We work to promote the Passivhaus standard and to foster a greater public understanding of its significance. And we do that by encouraging the exchange of Passivhaus knowledge and communicating with the media, the general public, governments, and the entire range of construction professionals. Today, you'll hear from the founder of the Passivhaus Institute, Professor Wolfgang Feist. He's a seasoned expert in the field of building physics, and Professor Feist became well known for his work to develop the Passivhaus standard and built the very first in 1991 in Darmstadt, Germany, where the Passivhaus Institute is also located. Later, in 1996, he founded the Passivhaus Institute to further the important research, and today it employs over 60 people from all over the world, and it continues to develop tools, capacity building programs, and methodology to build better.
Yeah, thank you so much. This is Wolfgang Feist speaking from the first Passivhaus in Darmstadt. Thank you, Georgia, for that introduction. I'll give you a short presentation about the contribution of the building sector to a sustainable future. And what you see here, let me try that again. Okay, I want to begin with a quote from Carl Sagan, the famous astronomer who had a television series Cosmos in the 90s, and the people from America might well remember this guy. He's speaking about the Earth, and the Earth, it's the only home we have. There is no hint that help will come from elsewhere to save us from ourselves. Yeah, and it was not prophecy. He knew a lot about human beings and about our problems we have here on this planet. And we have a huge problem right now. We are destroying our atmosphere. We are adding greenhouse gases to the atmosphere in such an extent that the living conditions on the planet will change rapidly. And they change not in favor of the human civilization. Well, life will go on planet Earth, but human civilization needs a certain climate on this planetary surface, and that's the problem. Now, I won't talk much about the problem. If you are interested to hear more about the problem, there will be a presentation also from a colleague from metrology, and he will give us an introduction in the latest research results about what the impacts of climate change would be. I have a much better presentation here. I just want to ask everybody to switch off their microphones right now, because there might be interference if you have your microphone on. So it's easy to just switch that off during the presentation. So I want to talk about the solutions we have available, and what you can see here, that is the development of the energy consumption, the primary energy consumption in Germany. Now, it's not because I'm a German and because I love Germany. I will be very skeptical about the German politics during this presentation also. And it's just because these data are easily available for me. And what you see here is that we have had economic growth in Germany in the past 30 years, and that the energy services have been growing. So there is living area added, there is more cars, there are further traveling, and so on. So lots of additional goods which have been produced by the use of energy on the one side. But on the other side, we see that the overall total primary energy demand in Germany has been decreasing now since 30 years, and it is decreasing by 2% per year. It's interesting. So the whole extra benefit of energy services and also this reduction of the primary energy demand, this was all achieved by improvements of energy efficiency. So that's a huge contribution. Already now, almost nobody is speaking about that. This is something I'll be highlighting in my presentation right now. We also added renewable energy to the energy generation. This is what you see here. Now you might have in mind that Germany is producing half of its electricity by renewable energy, and that's true. This is just showing you that electricity so far is not the main part of the energy consumption. A very high part also is heating, and that will be something we will be talking in this press conference. So what you see is that we reduce the total amount of not sustainable energy, fossil fuels and other not sustainable energy sources quite a bit during that time. It will take just another 50 years if we go on in the same path to reduce the non-sustainable energy to zero. Well, maybe we can do a little bit better and a little bit faster, but overall, this shows that there is a success, and we should recognize this success, and we should positively communicate it. And I know there are similar developments in a lot of other countries, and yes, it's possible. We can do that. So I'll just show you some of the contributions which are possible in the future to even improve that development. So what you see here, that was in the past. We have substituted the old inefficient technology like the incandescent display by more efficient LCD displays. And that was a reduction by 75%. And a lot of people think now we are efficient enough, but well, we can do it even better. So the newest developments in technology now already available for several years is the electronic ink or electronic paper display, which doesn't consume any energy at all for the display. Well, it uses a little bit for the change of the display. So this is less than 1 watt. So another 95% reduction from where we are now. So at the end, that will be a negligible consumption for displays. And this is just one example of this developments of a very high energy efficiency. The same thing, and that's where the Passivhaus Institute has its core competence in, can be done within energy in buildings. So the most important energy consumption in buildings is the heating. And what you see here is a typical old German building that has a consumption of more than 200 kilowatt hours per square meter a year alone for heating. The heating makes up more than 30% of the total energy demand in Germany and about 40% in the whole European Union. So it's a very huge part. So what we have done with that building is there was a retrofit project. And on the right-hand side, you see the building after retrofit. So it's not only the improvement of the energy efficiency, there have also been balconies added, huge window areas for people. There were very small windows in the past, so now they have been a little bit bigger. So this all was improved in building additional, of course, insulation on the wall surfaces, on the roof, and so on. So the measured energy consumption was reduced from the before value by more than 85%. And these are measured values where you can see how successful such an energy efficiency improvement can be. And this is done by the standard of Enerfit, which is somehow the Passivhaus for existing buildings. Even better can be the results for new construction. So this is the very first Passivhaus. I'm speaking from this part of the building. It's a row house, and there are 4 units in total. And this right-hand side unit, this is the unit I'm actually sitting up in this working room here up on the roof side and the south side of this building. And these are the measured consumptions in the past 30 years. So what you see here is that the overall consumption for heating was down to 8 kilowatt hours per square meter in year. Well, it's a bit up and down dependent on the climate. But you see in comparison to the new German standard, this is the the existing standard by law for new construction in Germany right now, it's a reduction of more than 86% again for the heating energy, which makes up the most important part of the energy consumption of a building. So also this is a major contribution to the reduction of fossil fuel, and we will see at the end, this makes it possible to also substitute this energy by renewable energy. Well, how to add renewable energy? We all know about photovoltaics. So photovoltaic system we have here on the facade and here on the roof of that building. In total, it's 4 kilowatt peak. And here again, these are the measured energy consumption, complete energy consumption in that building for heating, 10 kilowatt hours per square meter a year. The demand for domestic hot water, that is the energy which was really consumed by hot water, about 11 kilowatt hours per square meter a year, and the electricity consumption for household electricity, that's for the computers and the light and so on, was also in the range of 11 kilowatt hours per square meter a year. So now let's look on the annual distribution of these consumption. What you see here, the green part, these are the household energy consumptions in this building. From month January to month December. And these are the electricity consumption for preparing of the domestic hot water with the domestic hot water heat pump. You see it's quite low, and these both consumption, they are spread along the year almost at a similar level. But when you see the heating, this is the electricity needed for the heat pump for heating, and you see that is very much concentrating during the winter. Now I just add the energy which is produced by the photovoltaic panels, and this is the yellow part. These are this is the electricity generated by a photovoltaic panel, and you see it's concentrated during summer. So we have a lot of additional photovoltaic available during summer. We make that available through the grid. This is one reason why you need an electricity grid and connect to the grid. You can deliver that energy also for other people who might use it for their cars or might use it for industrial production. Now, if you are connected to the grid, you can also use wind power, which is distributed by the grid. And you see here, this will add quite a bit of energy during the winter, because the production of wind energy in Europe is a little bit higher in winter than in summer. But still, there is a gap of energy during the winter. And this gap is almost all the electricity we need for the heating. So there has to be additional energy generation. This is a plus energy, a net zero energy building, even plus energy building, because we generate much more renewable energy than we need. But there is still a remaining demand during the winter, which we will have at the end to fill in with seasonal storage. And seasonal storage is a quite expensive thing. I won't talk too much about seasonal storage, but I'll tell you that that's something we want to avoid as good as possible, because it's extraordinarily expensive. But if the consumption is so low as it's shown here, it's possible to generate that. Now, there is another part of the energy which is being consumed by the construction sector. This is the upfront energy used to build these buildings. And we can improve that also. So if we build by sustainable materials, which are available in a huge amount, we have a lot of straw, for example, which can be used for insulation material. This is an example of a passive house construction detail, which is certified, which can be used to build passive houses completely from sustainable materials. And so we can reduce in this way also the energy needed for the construction of the building, which makes up about 25 to 30% of the overall energy which is needed for a passive house. In a passive house, the heating is so much reduced that it's almost negligible. But in an ordinary building, of course, you have much more consumption for these occupational use, and that's the very first step we have to go. Now, it's not only that a passive house saves energy, it's also saving a lot of money. So the savings in energy, that's about 45 kilowatt hours per square meter each year. But the extra investment in Germany is in the range of 83 euro per square meter. That's only the additional investment for Passivhaus. So some buildings are even less expensive, and of course there is no upper limit because you always can add costs in a construction process. But this is the average value, and so this is not only affordable, it's also worth it. So you will have much lower total costs, lower total life cycle costs using the Passivhaus approach in Europe at this time, after a quite steep learning curve we have had introducing these standards. Now let's have a look on how can that help us for the problem I've mentioned in the beginning of this presentation. That is, if we have the business as usual development, that would be the red line in the emission of carbon dioxide equivalent to the planet's atmosphere. It's almost straight line. It's also quite interesting. I'm not going to analyze that right now, but that's it. This is the overall planetary growth in GDP. If that would go on like it has been in the past, it would be quite a challenge. But if we reduce that growth, say from 2040 a little bit, you see that the additional efficiency we just add normally every year in the business as usual. This is Bau business as usual efficiency. We can stabilize the overall the primary energy demand on the planet. But that's not enough, of course, because we have to reduce the fossil energy use. So the additional efficiency, that's what I have been speaking about, the efficiency which comes from even improved efficiency standards, like the Passivhaus, like the electronic ink screens, like the electric cars. If we add that to our portfolio, we can even reduce the primary energy demand. And now we can fill in renewable energy. Now this is a conservative approach. I just said that if we fill in renewable energy at the same rate as we have been developing non-sustainable energy in the past. Yeah? So we have built power stations, we have built additional oil drills, and so on and so on. So if we add in the same velocity, then these renewable energy sources, we can reduce, you see on both sides, this amount of non-renewable energy, so that at the end, we will almost fulfill the goals for the reduction of the greenhouse gases in the atmosphere. So it's possible. Now, what are the components of this development? Well, the Passivhaus Institute is engaging in a lot of activities to make that transformation possible. And what you see here is one of these activities. This is an exponential growth. And there are not many developments on this world where you can enjoy having an exponential development, and this is one of them. This is the development of Passivhaus suitable components, certified components. These are windows, insulation structures, thermal bridge-free construction, air tightness products, and ventilation systems with heat recovery. All these things you need to improve energy efficiency in buildings in a very strong way. And so this has been increasing all the time. So the Passivhaus Institute is giving advice to the industry to introduce these kinds of products, to make them available. So this is selling efficiency to the customers, to the whole sector, in order to build these incredibly energy efficient buildings. The Passivhaus not only saves energy, but it also guarantees you optimal comfort, because the surfaces are warm during the winter and they will be cooler during summer. You will have healthy indoor air quality, which is quite important, as we have seen in the Corona crisis right now. And we can speak about that later on, why improved ventilation is a good idea. for hygiene in ventilation. We have reduced total cost, as I have shown you. It's definitely a solution for climate protection. It's sustainable growth, which is possible here in this development. And what I think is even more important in a time of crisis like we have now, it's creating employment, but not just some employment, but it's a employment with a lot of participation and understanding by the employees, so you can understand what you are doing here, and so there is a good participation in that development. So these are win elements, win to the power 6 by using the energy efficient, the highly energy efficient developments. So there are lots of examples which have already been built to Passivhaus standard worldwide. I'm not talking about all of these. These are all certified Passivhaus buildings. So we are not speaking about a theoretical concept, not something which has only been demonstrated, or there are only a few examples. No, it's a lot of examples, 28,000 certified dwellings around the world and in all different architectural styles. So it's not something which is just being sold by a company or by an industry. It's a concept which can be used by everybody. It's free and open for everybody to use that concept. Just want to highlight two of these projects. This one I'll be talking in the next slide, and this one is a refurbishment project in Paris. So you see that there is a huge scale of different architectural approaches to reach this Passivhaus efficiency. So this is a project in Philadelphia, near in the US. Pennsylvania. It's terraced houses in a affordable housing project in the US. So we have some guests in the US, so they know how difficult it is in the US to do something like that. It's been built by the occupants themselves, and it has to be really cheap and really easy to build to be able to realize such a kind of project. So I love that project very much. It shows that it's possible to introduce these highly energy efficient standards everywhere on the planet, even if you have to build it to a very low cost. That's possible. That is what's been shown here. Another project from Spain. This is in Bilbao, a residential tower, which is built to Passivhaus standard. All these projects certified. I'm only talking about the certified projects here. There have been whole developments like a new city district, Bahnstadt in Heidelberg, that was a former railway station. That's where the name Bahnstadt comes from. It's a mixed-use residential and non-residential new city district. 6,000 residents so far, and there's a lot of examples in these buildings. And now this is also Bahnstadt. It's another development in China. It's in Darbedian. That was the place of the 21st International Passivhaus Conference. That is 1 million square meter of Passivhaus development, all certified in China. So China is really going that path of a highly energy efficient development. And I'm really glad to see that, because without China, we won't be able to tackle climate change in the future. What are the other contributions the Passivhaus Institute gives? Well, we have a Passivhaus training available, and you see in that map all the participants which have been taking place in that training all around the planet. So the concept is available everywhere. It's a method you can apply in every place. So it's not just a flown-in construction. It's not just a by helicopter placed building. No, it's a concept which can be realized by architects at any place on the planet. And in order to have the know-how, that's the only thing you need. We have these worldwide training programs where you can be a Passivhaus designer or a Passivhaus consultant. Also for tradesperson, this is available. And then there is, of course, the communication. The best way to communicate such an innovative approach is to speak with the occupants of the Passivhauses. So we have these international open days for Passivhauses, so where people invite you into their own living room to have a look. Well, Now in the time of Corona, it will be a little bit difficult. So the next event of the Passivhaus Open Days will be a video event, a virtual visiting of these buildings that will take place on June 26 to 28 in this year. And I think Georgia will later on tell you a little bit more about that event. Then we have also a Passivhaus Architectural Award, which is open for architects. We want to emphasize that there can be quite good architectural quality using the Passivhaus approach. So there have already been 2 of these Passivhaus Architectural Awards, and the next one will be open up to 2021. We have the International Passivhaus Conference, which is the exchange between the professionals in the field. Last year it was in Gaoyuan in China. This year it will be in Berlin, and of course it will be a virtual conference right now. And there will be a lot of contributions from several parts around the world. We will have another press conference when we have the full concept for this quite new concept of a virtual conference. With my last slide, and the question was, can we still solve the climate crisis? And my answer is yes, we can. If we decide and if we act meaningfully, and if we act in accordance with this decision, which isn't always easy, I know. So I will close with another quote from Carl Sagan, where he says, well, to me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we have. Thank you so much.
So Daniel's question is, can you confirm that in a Passivhaus, one is much safer in these times of the COVID crisis?
Well, if it's a certified Passivhaus with certified component, then yes. Because we have only fresh air delivered. There's no circulated air inside of a Passivhaus dwelling. And the fresh air is also filtered through a MERV 11 to MERV 13 filter. So that means that there is almost no virus load in these buildings. Well, of course, if you meet somebody inside of your building and he's coughing at you, you are not safe. That's for sure. But the airborne part, you are much safer in a Passivhaus than in any other solution, despite of very clean room developments, like in a factory for integrated circuits.
The corona crisis has shown that a lower urban density allows a better health response. Should the Passivhaus concept give more importance to urban organization?
I don't agree with the assumption. It's not true that in a denser situation, the crisis can't be dealt with. And there are interesting examples all around the world demonstrating this. Look at China. China has a lot of very densely populated areas like Beijing, Gaoyuan, and they dealt with the crisis very efficiently. So there's no problem. If you don't trust China, you can look into San Francisco. I have a very close look into what they have been doing, and they have also dealt with it very well. Well, Los Angeles didn't. So you see, it's another question. It's not a question of density. But the question of density, there's another reason why I am not so much in favor of these very high density developments, which a lot of architects are. So that's an ongoing discussion. And I have other reasons why. See, also traffic is much more a problem in these very dense populated areas. So, well, let's look into this a little bit deeper in a scientific research also. What I can tell you is that actually the Passivhaus started with a not very high, but also not a very low density approach. That was these row houses. I've shown you in the presentation, and I'm sitting in one of them, and I see that this is a real nice place to be. It is you have and you can have a density which is almost as high as with high-rise buildings, and you can still have some green areas all around it, and you can still have a possibility to do your walk and to do your bicycle around. You can have your garden and so on. I think all these things have a very high quality for the people. This is why I prefer such kinds of development. And the interesting thing is, you can look into that, it would be possible that most of the world's population, even if it's 10 billions or 11 billions, could live in such a density in the future if we do it in that way. So that's an option. That might be a possibility to go. Well, there are these densely populated parts, and we need solutions also for these parts, because you just can't stop right now having them populated. You know? Think about that. That would all the people from Beijing or from New York or from even Vienna should go to if we want to move them to another place. It's impossible. It's impossible within a time of say 10 years. Maybe possible in 50, 60, 80 years. That's the time it took to create this very densely populated areas. Now we have them. Now we have to deal with them. And then Passivhaus is a solution also for the densely populated areas.
Yeah, thank you. Fantastic presentation, Professor Feist. Lots of very interesting points made. I just picked up on the point that you raised about embodied carbon. It's an issue that we've been starting to look at more in a lot of detail recently in our magazine. And the question really was whether the life cycle assessment methods should take account of the robustness of a given building or building standard when projecting the lifespan of a building. I took note of the paper that you co-authored on the first Passivhaus, this sort of 25-year review, which I thought was extremely important. And you get a sense some buildings may, poorly conceived buildings may only last 20, 30 years in some instances, and some other buildings really are built to endure. And there's a sense that this is not always reflected in the LCAs. So have you looked at, is this a subject that you've looked on in detail? Have you discussed this with people involved in LCA, and do you think it's something that's worth pursuing?
Well, it's a good question, and yes, of course, there are a lot of parameters in these LCA calculations, and that makes it sometimes a little bit intransparent. There are a lot of people who try to manipulate these parameters in a way to give the impression that their specific thing they want to sell is the most important part. That is what you always have, and so it's a scientific question what to do here. And I think we should be aware of these parameters. And we are at this moment working on a tool which will be made available so that everybody can check this influence of these parameters. And one of them, you already told, is the lifetime of the construction. And that's, of course, very important. That when you use a plastic material just for 5 minutes as a bottle, and then throw it away, or if you have it in a building where it might be used for 200 years, this would be a very good time for a building. We have a lot of buildings which last that long here in Europe. So this is a very important parameter, and we have to take that into account for doing good LCAs. And this is one of the problems, but only one. There are much more. So much more. How do you account for renewable, sustainable material? because it's also storing some carbon. That's for sure. But on the other side, you would have to have a reference case. What would happen with that carbon if you don't store it in the building? Yeah? All these things have to be taken into account, and it's not done properly so far. And that's one of the reasons why we are a little bit cautious in this field. Yeah? So what we definitely know is that the major amount of carbon dioxide emissions so far in the atmosphere, they are coming from the energy consumption. And you can see where the energy flows to, and the energy flows to 30% of heating. And then there is 20% of industrial production. And in industrial production, a part of it is, of course, building materials, but not the major part of all. So you can already see what is the distribution right here. And that's a part we can be sure about. And there are other things we are not so sure about it, like what really happens with materials which are grown on the field or grown in the woods. These are all things there is ongoing research, and I hope we will have results soon. So thank you for the question. And yeah, another thing we can be sure of is it's always good to use a construction material as long as possible. Now, this is possible for all types of material. It's possible for concrete, and it's also possible for wooden construction if it's been done in a proper way. Yeah? That's the only thing. Yeah? So wooden material may deteriorate earlier if you don't do it in a proper way, but if you protect it against humidity, that's the main thing you have to do. And this is what we know in the Passivhaus field, how to do that. Wooden constructions can last for not only for decades, not only for centuries, it can last for thousands of years. We have seen that in the graveyard in Egypt. There were wooden construction which were still preserved for thousands of years. So this is possible, yeah. So and that's after the energy consumption, the longevity of a material might be the most important criterion for sustainability.
How does the Passivhaus Enefit standard address the challenge of renovating building stock on a large scale?
Yes, there are different approaches to the Enefit standard. One approach is a performance approach, like in the new construction, but taking into consideration that in existing buildings you find some of the boundary conditions just fixed. Some things that you just can't change. Yeah? That is why lots of architects don't like to do retrofits, because we just have to follow what has been designed in the time before. Yeah. So and that's why the Enefit standard is from the Passivhaus standard, also in the performance part. But there's also a path for Enefit using the components, using improved components. So if you just add up Passivhaus components for every component you retrofit in the building, you will end at the end, if you always using Passivhaus components, with a reduction of the energy demand, which might be between 60 and 90%, and that's also a path you can go. So these are the ways you can use Enefit. And that, of course, will always bring you the best possible result for your retrofit project. And this is what we try to have the tools available for, so that you won't invest unnecessarily in very expensive things which you really don't need on one side, and on the other side, you will always invest in sufficiently good insulation, for example, or windows, so that at the end there will be no regret. Yeah? So if you now install new windows and the handicraft says, oh, it's an old building and your wall is not insulated very well, so it's not worth it to install a triple pane window. Now, 5 years later, you insulate your wall, and now the wall is well insulated, and now you regret that you have only these double pane windows. So you see, this is something you should take into account from the very beginning, and this is what Enefit does.
Proper planning indeed. And maybe that's a good opportunity to mention when we're retrofitting on large scale that the Institute has developed the district pH tool, which is still being added to, and it is designed to help full districts be retrofitted and plan ahead, as Professor Feist mentioned. So looking at countries and regions with different socio-technical contexts, what would be the challenges and the barriers to building passive house in regions such as India or Russia?
Let's begin with regions like India or Bangladesh or China. The interesting thing is that the passive house is not necessarily a high-tech solution. You can build passive houses by homegrown materials, like you have seen with the straw bale construction. You can build it by wooden materials. So the only thing needed is a better education, is the know-how here. And now this is very interesting because having this know-how available will not only make it possible to build these types of improved construction in these countries, it will also improve the education level of the people in the country. So that will help with the biggest problem we have on this planet, and that is education. So it will help a lot in all parts. There has even been a publication about that by Mrs. Zhang in China, who has been doing development of passive houses in Chinese rural areas. And she has reported about the experiences they had with the people in these rural areas using this type of technology, and that's a very, very interesting development.
A question from Mark: Are the energy savings of the passive house standard reliable?
Well, there is a late peer-reviewed publication on exactly that question in energy efficiency. That's the International Journal for Energy Efficiency. That has been published by co-authors Mark Sidal and others, and it's freely available on the Energy Efficiency Journal. You can read that, and we might also communicate a link to that. That was a research done by a lot of different scientists all around the globe, looking into passive house developments which have been built in the past, measuring the consumptions of these buildings. Now, some of those are now more than a decade in use, so we really know what they are consuming, and we know it's reliable. Yeah? So we can really reduce the energy demand of existing buildings by more than 80% using that technology, and for new construction even more. Yeah? So that at the end, the energy consumption for heating is almost negligible.
And that's a good point to ask. What expectations would you have from the European Green Deal for promoting passive and energy efficient construction?
Actually, the European Green Deal is a very, very engaged and substantial development taking place. I was really surprised that the European Union decided to go this path, and they seem to be really committed to do so. So I have a huge hope in the development in Europe. It's a big chance, and the European Union seems to have realized that there is a big potential for economic growth in that sustainability sector, and that's the important thing, that we can in this way transform our societies into a sustainable development, which also includes, of course, more local production. All these energy efficiency things can be produced on a local basis where materials are available everywhere. The know-how can be easily spread. There can be competent people, planners, designers, and scientists who can help with that. So this is a big chance for Europe.
I'd mention at this point that the International Passive House Association collects a list of policies and funding options for passive house from all around the world, and it's constantly updated. So as new policies that implement passive house are put into practice, we add them to the list. We also have a list of crosswalks. So when the passive house standard has similarities with other building standards that focus on other aspects of building. How much more does it cost to build a passive house compared to standard homes in Germany? In New Zealand, they advertise 15% more than the standard.
Yeah, that's interesting to see. That was the 15% was also the starting point in Germany, say 20 years ago. Right now, I have shown some figures in my slide. We are in a range on between 3 and 8% of the construction costs, extra costs on construction for passive houses. And there are some examples where we don't have any extra costs. That's also possible. It's all the construction costs of buildings. They are quite different. So if you look into the construction costs, you have in mind maybe 2,000 euro per square meter. That's an average value for Germany for normal buildings. But if you have a closer look, you'll see that the 95% interval is between 1,400 and 3,800. So there is a huge spread. Can be very expensive, can be very inexpensive. Now, the passive houses, they are they don't have that very huge spread. They are in between 1,600 to 2,800. Well, of course, you could also build a very expensive passive house if you really want to. If you want to include a swimming pool and things like that, there's almost no upper limit to these costs. But in the average additional costs for constructing passive houses in Germany right now is in the range of 6%.
And a good segue from that is to ask, how does passive house support the economy?
Well, if you think about developments in economy, that is, there are of course always different goals people have, and in my view, the economy has to be helpful for the human beings, has to be helpful for the people living in the country, and so what do we, so you have to ask yourself what do the people need on the one hand, what do we want to have on the one hand, what is the role of employment in the country. So there's a very broad philosophical discussion here, and what this energy efficiency approach can help us, it can create employment on a regional and local level. It's very easy to see. If you retrofit buildings, you need a lot of employed people on the site. It's not possible to substitute them just by some factories in wherever, India or China or whatever. You need the people who are installing these things on the site. And now that has a lot of aspects. One aspect is it's creating local employment. The second aspect is it's small and medium enterprises, and that is the major basis for a really thriving economy. It's not the big corporations. It's the small and medium enterprises which make up 70 to 80% of the whole working force. It creates employment for people which are informed about what they are doing, so they know what they do, that they can enjoy what they do. Yeah? So that's another aspect which I think is very important. So I just hate that there is that British approach of what do they say? Work-life balance, as if work is something which you want to get rid of and life is all the other thing. And I think it's a completely wrong concept. we can enjoy our work. Most of our employers at Passivhaus, we just enjoy their work. Also, lots of our partners in industry who are producing these energy efficient components, they enjoy their work. So this can be a major contribution to a transformation of our society into a completely better, completely more enjoyable way of life.
How is Passivhaus complemented by renewable energies, and how are they best integrated?
I had one slide about that, showing that the energy efficiency and renewable are somehow complementary parts of the same thing, nearly a sustainable development. On the one side, you reduce the overall demand for energy, especially during winter. And on the other side, you add sustainable energy generation, mostly during summer. And this all fits together. So the lower the total energy demand, the easier it is to have a fully renewable generation of energy. And that has been shown for countries like Sweden and Germany, and also for parts of the United States of America, that it is possible to have a path combining energy efficiency and renewable energy to get rid of the almost all of the fossil fuel. Well, you don't have to reduce the fossil fuel to zero. This is another thing which is very often got wrong. The planet has some tolerance for, say, 2, 3, maybe even 5% of the fossil fuel use we have at this moment. We could go on with that for a couple of centuries without any problem. So if we don't reduce it to zero, but only to a very small number near to zero, it would be sufficient.
How do you propose to increase community participation? The press obviously plays a role, but what other options are there?
Well, we engage in that, and Georgia is one of the people who is really doing a lot of work on that. That is all the communication parts, like the press conference we do right now, like the Passivhaus conference we offer, which is also open for everybody to join. It's not an expensive conference to join. And we give advice to the construction sector, given advice of how to improve windows. We have done that everywhere on the planet. This is what goes on. We have these open days for Passivhaus, so and we will produce even more. There are lots of videos available in YouTube made by Georgia and others, showing people living in their Passivhaus and how the results are. So it's all about that is going to be communicated in a way which is done in a good way. What I have seen so far, New York Times has, for example, done a quite good reporting on Passivhouses so far, and there are other medias who might do that in the future. Yeah, why not? I think it's possible. It's a question of responsibility, and it's not only our responsibility as scientists. Yeah, we have a lot of responsibility, but it's also responsibility of the press.
If I may add to that, we do have a lot of community participation, not only in Germany where we're located, but around the world. In fact, I see some of the names here, representatives of the Passivhaus community from around the world. Paul is in Australia, where I'm originally from myself. We have our Spanish affiliates here. So we have a strong international network of Passivhaus experts who represent the standard in their own regions and countries, and they do a really amazing job, which can also help the press if you're looking to do a story on Passivhaus in your own region or country. We can always put you in touch with those groups. Perhaps adding to that, Andrea has asked, do you think that consumer demands for construction will change?
Well, that's also, again, a question of what you communicate. Yeah. So in this world, it's almost all about advertisement. Yeah. So people buy what the advertisement tells them, And so if you start a huge advertisement for just not insulated conventional materials, a lot of concrete and so on, and these are people with a lot of money, I cannot promise that we consumer will be more acting more responsibly than all the advertisement that is thrown at him all the time. Huh? And we are not the guys with a lot of money. So that's, again, it's a responsibility also for the press, of course. Yeah, if the press is also reporting on the better solutions, despite of the money for advertisement, which is spent by all these people who still want to sell the old-fashioned stuff.
So what do you think is important to improve in the education of future architects besides becoming a passive house designer?
Well, as I was teaching building physics at University of Innsbruck, I learned that a lot of our teachers in building physics and in other engineering parts, we give so boring lectures that it's really, I understand that the architects don't like that, so we have to change that. Yeah, so it has to be a integrated part of the architectural education to make these things understandable. And I think this is quite important. If you build buildings, buildings are of course also artworks. Yeah, it's art, and an architect is an artist. That's true. But the building is also occupied, so there are people living in these buildings, and you have to keep the living conditions of these people in your mind when designing these buildings. And that has to be an integral part of the education of architects. And it gets a little bit lost these times. So we want to reintroduce that. Yep. There are lots of aspects like this, and it has to be done in of course, in a way which is more rooted to the real thing. So when I was in Sweden 30 years ago, meeting Bo Adamson, the partner in the development of passive houses, we were at architectural school there, and the architects were outside, and they were working on brickwork. So that was part of their education, and that's gone. Yeah, so lots of architects are at this moment just working in abstract levels of whatever. Yeah, it has to be connected to the real thing. Yeah, this is something where the work we have been doing might be a contribution.
A question about getting into the industry from Eli. Do you have any advice for someone who's interested in starting to work in this field in design?
Yeah, well, there are a lot of institutions right now who have good educational resources for introduction into energy efficient design and sustainable design. And one way, of course, is always to first have a look into Passivhaus, and that's passivhaus.org. And then also contact the International Passivhaus Association, and they will find you a way to be included in the development.
The Institute's also developed a range of different capacity training programs for designers, but also for tradespeople, and that offering is always being expanded to cover other stakeholders in construction. Do you think that a top-down or a bottom-up approach is most helpful when increasing the adoption of the Passive House standard?
Well, from my own development, I always prefer bottom-up developments, and this is how Passivhaus started. But at this time, we are in a situation where, in my opinion, it doesn't matter whether the good solutions come bottom up or top down, because we are desperately in need for the good solutions. So every contribution which is possible is welcome. So some regions of the world, there might be top-down approaches, and yes, it might help. In other parts of the world, there might be bottom-up approaches, and they might help. What is dangerous is what I see. There are a lot of top-down things happening in this world right now, which are top-down in the wrong direction, yeah? Which are forcing people to do the wrong thing. That's the dangerous part.
Yeah. Do you believe that the concept of sustainable development is suitable for the challenge of keeping the planet alive?
It is suitable. That is not a question of belief. That's also some of things from a scientist. We are a little bit desperate right now because everybody thinks that it's a question of belief, or it's a question of what the majority believe, or opinion, or whatever. No, there are some things which are scientific facts, and that you can save 90% of the energy by improving your building construction. That's a scientific fact. So you don't have to believe in that. It's true whether you believe it or not. It's like that the Earth is going around the sun. That's true whether you believe it or not. It's that the coronavirus, if you are older than 60 years, it can kill you. It's not a question of belief. It's a question of scientific fact. So there are some of these facts. And one fact is, yes, with the improved efficiency in construction and in refurbishment and in retrofit, we can still save this development, and we can still avoid the dangerous parts of climate change. Well, of course, there will be climate change because we have already emitted a lot of carbon dioxide to the atmosphere, and it is changing the climate. And the climate will go on changing for at least the next 50 years, even if we would stop the emission completely right now. That's again the same thing like with the coronavirus. You might now remember when we did social distancing in mid of March, most countries began to have some social distancing. And then the number of infections and the deaths, they kept on growing and growing and growing because all these people had been infected before the distancing had been in place, yeah? Because it takes some time to develop after infection, to develop the symptoms. Yeah? And that's the same thing with climate change. So we have to be aware of that. So we have to start now with improvement. At least we should have started 20 years ago. I can't change the past, but at least we should start now.
Very important point brought up. I'd like to say a big thank you to everyone who joined us today. We will make the presentation available as part of the press pack.